Hi everyone, here's your next question. A water tank on a farm near Swift Current, Saskatchewan, holds 6,000 liters. Okay? Graph A represents the tank being filled at a constant rate. Graph B represents the tank being emptied at a constant rate. Okay, here we go. Identify the independent and dependent variables here. Okay, so let's take a quick look here. Now, based on the way the graph is drawn right now, it should be clear what the intention is, because we always put the independent variable along the horizontal axis and the dependent variable along the vertical axis. Okay, so in this case here, based solely on just the way the graphs are being drawn right now, the independent variable, okay, is going to be time, and the dependent variable, okay, is going to be volume. Determine the rate of change of each relation and describe what it means. Okay, so let's take a look at, for graph A here. Now, rate of change, what I'm referring to is how quickly the dependent variable changes values for a change in the independent variable. Remember, I control the independent variable. That's the whole point. If you want to compare this to a science experiment, the independent variable is the manipulated variable. So what I'm curious is how that affects a change in the dependent variable here. So let's just take a quick look here. Grab a couple points. Okay. In the first 80 minutes. Now this seems to be constant. Okay, it's just a smooth line here, straight line. In the first 80 minutes, when I increased 40,000 liters. Okay, it took 80 minutes there. So I had a positive change of I said 40,000. I can't believe I did that. 4,000 liters over a change in 80 minutes. Okay? Now, if you take and divide that out, okay, 4,000, and I'm just going to do this on my calculator really quickly here, even though I know what the answer is. I just want to make sure that I'm not going to make a fool of myself. Okay, 4,000 divided by 80, this is going to be 50. But notice that the units, there's nothing to cancel the units here, so it stays liters per minute. Okay? Now that's basically, this is how fast it fills. 50 liters per minute. In graph B, sorry, and I'm sorry, I shouldn't have said A equals. That's incorrect here. I should have said the rate of change, okay, in A is equal to 4,000 liters over 80 minutes. Now, for B, the rate of change of B, and we'll use M typically to refer to that. In fact, maybe I should come back here and I should change this to M, okay, M of A. And if you haven't seen that notation yet, it's coming here. So M of B is going to be, well, let's take a quick look here. So what's happening here in B, oops, sorry. Again, looks like a straight line, so it's a constant change here. I go from 6,000 to nothing, so that's a loss of 6,000 liters. And I want to make sure that I am plugging the negative in there, because whether it's increasing by 4,000 or whatever, or decreasing, I need to identify that. And it decreases. Now, we got to think about how much this took here. From 0 to, well, that's going to be 60 minutes. And so what we're getting here is we're getting 6,000, okay, divided by 60. Or essentially what we're doing is we've lost 100 liters per minute. Whoops, sorry. So what does this represent? This represents how fast the water drains. Now, finally, what are the intercepts and what do they represent? So, well, for graph A, okay, my horizontal intercept, okay, where I hit the horizontal axis is going to be, well, 0. Okay, my vertical intercept is going to be also 0. Now, what does this mean? Well, what this means is, okay, this means when time is 0, the volume is 0. Or, better stated, initially the tank is empty. That probably makes more sense than the way we're describing it up there. Now let's go to B. My horizontal intercept, okay, let's look at the graph here. My horizontal intercept is 60. Now, at the horizontal intercept, note here that volume is 0. So what this means is, therefore, it takes, okay, what this is suggesting here is it takes 60 minutes to drain. Okay, my vertical intercept, okay, I got to look at the graph again. My vertical intercept is 6,000. Sorry, I should probably put units here, 6,000 liters. But notice that at this point here, time is 0. So what that means is, therefore, the initial volume is 6,000 liters. In other words, we start at 6,000. So when we talk about intercepts here, remember that one of the variables is going to 0, and that's significant, okay? And that's what we're interested in often is these extreme values here. When one of the variables is 0, what happens to the other variable? But in context, you need to be able to interpret, okay, based on the units primarily here, what that means in those two cases.